So we've just been talking about how adaptive radiation could actually be able to explain the diversity of life on Earth. If we start with a common ancestor, and then there are genetic mutations and variations, as we accumulate those variations, we might actually see speciation events that lead to tremendous numbers of different species. And we're moving on to talk about, well, how do we group or classify those species? Now, some species are still living today, and they're called extant. E-X-T-A-N-T. E-X-T-A-N-T. Extant. But we can't forget that there are extinct organisms. There were 5 major extinction events here on Earth that caused tremendous opportunity loss for the organisms that went extinct, but opportunity gain for the organisms that then weren't having to compete as much. And so we see tremendous amounts of living organisms, and we might want to group or classify them. Basically, identify who's similar and who's different. Now, when we talk about organisms, there are multiple correct names. There's something called the common name, and this is based on the language that's spoken versus scientific names are actually based on the Latin language. And the Latin language isn't spoken anymore. And so this is why it would be difficult for us to go around using scientific names for organisms, and it's much easier to use common names, such as brown bear or polar bear. But the problem is that then we start to talk about koala bears. And how do we know if they're truly related? Common names are based on spoken language, and they do serve a purpose for what's called colloquial conversation, or the ability to speak and explain in everyday language. However, if we want to actually know something about an organism, scientific names are actually intended to provide information about the organism. Scientific names were originally intended to show relationships. However, what we're going to see is that most of these relationships were usually based on anatomical similarities, which, as we know, can actually be very different and misleading and not truly show evolutionary relationships. So we're going to see that scientific names and the whole category of nomenclature, or what we call taxonomy, actually must be very flexible. It should be able to change according to new information that shows better relationships. Now, scientific names you've already had some experience with this year. It is the genus name, which is always capitalized, and the species name, which is always lowercase. If you were typing it, it would be written in italics, but if you're handwriting it, you underline the 2 words separately. And so what we're going to see is that these names should provide us with some information. So for example, if I give you the name Canis lupus and Canis familiaris, you should be able to notice that they share the same genus name, which would mean they're more related to each other than any of these scientific names here in this cartoon. However, as we said, sometimes these anatomically based, this is actually wolf and this is dog, sometimes they can be misleading. And you're going to be reading an article that suggests that we need to change the name of the common fruit fly. It's currently Drosophila melanogaster, but some people argue that it doesn't really belong to the genus Drosophila. So we're going to see that taxonomy is a very difficult branch because we're always receiving new information. We do want to take a second to talk about how you find an organism's name. There is this tool called a dichotomous key. If you know the word dichotomy, you know that it means two different. A dichotomous key uses a question or a series of questions in a series, and those questions have two answers. The answer is either always yes or the answer is no. Those are the only possible answers. And so if we look at this dichotomous key, it says, does it have feathers? Yes. Does it swim? Yes. The organism you're looking at must be a duck. Does it have feathers? No. Does it have legs? Yes. It's a lizard. And so this is, of course, using common names. And you can see that if you start with any four organisms, you can design a dichotomous key to get there. So dichotomous keys are mainly used in guidebooks. So for example, if you were out camping and you got bit by a spider and you crushed the spider and you wanted to know what spider was this, it might ask you, is the body black or is the body brown? Does it have a red hourglass or not? And that will lead you to the name. We do have to be careful to always start at the very beginning. If I had started with the hen here at legs, does the hen have legs? Yes. No, it's not a lizard. And so the importance is that you always start at the very beginning of the dichotomous key and that you use the questions to help you get to the name. But this is only helpful if the organism is already named. If you're looking at a new organism, you need to be able to figure out what its name is. And so we're going to look at how we give names to organisms, especially scientific names. We want to do a little bit of history of classification. Where did this come from? So the history of classification actually started with a man named Aristotle. He was a philosopher, and he grouped organisms into two categories, plants and animals. But as we know, there's a lot more to classification than just plants and animals. And so a naturalist named Linnaeus actually created taxons, or levels of classification. Scientific names are based on something called binomial two-name nomenclature, naming system. However, when we go around talking about Ursus arctos or Homo sapiens, it turns out that there are many levels of naming. And again, these have to be very flexible because as we discover new information, we need the name to accurately represent the organism. So for a very long time, there was kingdom, phylum, class, order, family, genus, species, these levels of names. But what we recognize is that some of the kingdoms, remember there are 6, some of the kingdoms have more in common with each other. And so the current system of taxonomy actually starts with something called a domain. And then we have kingdom, phylum, class, order, family, genus, species. You do need to know the order, but here's a hint. Dear King Philip came over for grape soda. You can make up any sentence you want with these letters, but I've always remembered, Dear King Philip came over for grape soda. For the domain, there are 3 domains. There's the domain Eukarya, there's the domain Eubacteria, and there's the domain Archaeabacteria. Now each of these 2 domains have only one kingdom in them, but we're actually going to see that Eukarya has 4 kingdoms in it: plants, animals, protists, and fungi. And we're going to get into those kingdoms a little later in the year. We do need to know that there are 6 total kingdoms, and we're going to talk about those kingdoms in just a moment. Domain is actually the most inclusive. Inclusive. If we look at a domain, it includes a very large number of organisms. And then we use each of these levels to start to subdivide it. So domain Eukarya can be subdivided into kingdom Animalia. And there are hundreds and thousands of animals in the animal kingdom. So then we subdivide it into what are called phyla. And there are many different phyla for the animal kingdom. One of which is phylum Chordata, which means that you have a backbone. So insects don't belong here. They belong in a different phyla called arthropods. And so we start to see that the current system of taxonomy is intended to narrow down. And that's why this is drawn kind of as an inverted triangle, because the point is to narrow down to a single species. This species, we should know, means that it can mate and produce fertile and viable offspring. But if we want to know who's related, we can go up a level and look at who else is in the same genus. So species, the name actually helps, is the most specific name, and domain would be the most general name. An organism actually has 8 levels of its scientific name. You need to know how to write a scientific name, and you need to understand the general relationship between these taxons or levels of naming. We're going to spend the last few minutes talking just a little bit about the 6 kingdoms. Now remember, there are 3 domains. There's the domain Archaea, there's the domain Eubacteria, and then there's the domain Eukarya. And when we subdivide it, we see these 6 kingdoms. Of course, these 2, Archaea bacteria and Eubacteria, have a lot in common. They do not have a nuclear envelope because they are prokaryotic. These 4 all do because they are eukaryotic. Along with having a nuclear envelope comes other implications or effects, such as transcription and translation. They're going to happen simultaneously in eukaryotes because there's no nuclear envelope. We're going to see that they happen separately in our eukaryotes because they do have a nuclear envelope. We're also going to see that the ribosomes of our prokaryotes, we already know this, they're a little different, they're actually smaller. When you talk about your 2 prokaryotic kingdoms, there's a lot that they have in common. They both are unicellular, not multicellular. And they both have varied modes of nutrition. Some archaea are photosynthetic, some archaea are chemosynthetic, some are heterotrophic, and the same applies for both archaea and eubacteria. But there are some very important differences. Archaea are going to be found in extreme environment. They're going to be found where it's very, very hot, where it's very, very acidic, where it's very, very cold, or very, very salty. And so those are your extreme bacteria. Their cell wall, they do have one, check, check, but it's not made of cellulose nor peptidoglycan, versus eubacteria have peptidoglycan cell walls. Now for the most part, you already know the rest of this. You already know that kingdoms, fungi and plantae have cell walls, just made of different things. We will talk a little bit more about kingdom Protista. Some of them have cell walls, some don't. We're going to talk a little bit more about how fungi get their food. They actually are going to absorb their food and use what's called extracellular digestion, versus animals are going to ingest and then digest their food. So what we're seeing is that we have this variety of different living organisms. And so we're going to be stopping here, but we are going to spend a little more time exploring the Protista kingdom and the fungi kingdom.